One of the big goals of this unit is to develop your critical thinking skills and your problem solving skills. So as I mentioned, the area of a right triangle, there's a keyword of right that's been given to you here in the question. We want its area, and we know that when we calculate the area of a triangle, we're using base times height divided by 2, and base and height have to meet at 90 degrees. So if I can figure out which two sides meet at the right angle, are right to each other, I could use the length of those sides to calculate the length of my base and the length of the height so that I can then calculate my area. So what I did first is I did a little sketch of my triangle. I just kind of estimated where some points would go, and to me, I thought these two are the most likely to meet at my 90-degree angle. So by doing a sketch, I kind of organized my information, and then I saved myself a little bit of steps later, because by doing the slope of PQ, so the bottom one, and this, I found its slope was 1/3, and then I did the slope of QR, and it was -3. Since these guys are negative reciprocals of each other, I know those are the two sides that meet at a 90-degree angle in here. So that was helpful as a first step. So down here I wrote that we know that they're perpendicular to each other, so these sides can be my base and my height. So then my next step was to find the actual length of side PQ. So I went back to our distance formula that we learned earlier. So rise squared plus run squared, all square rooted, using Pythagorean theorem, gives us our slope, our distance. And when I did that, I actually reached back to my slope values that I found. So over here, I have my y2 minus y1, and that gave me an answer of 2, which I used right here. And then I also had a x2 minus x1, which gave me a value of 6, and I used that value here. Since I've already done the calculations, it makes sense just to reach back and use them to save myself some time and effort. And I came up with a value of the square root of 40, and I left it in its exact form so I can work with it later on in the formula. Then I went on to find the length of RQ, because my RQ and PQ meet at the 90-degree angle. Again, I used my distance formula. My x2 minus x1, I reached back here and I found that it was -2, so I put that in. And then I know that my y2 minus y1, I had calculated it to be 6, so I put that in here. And that length also ended up being the square root of 40. Now my diagram that I drew first is not accurate. It's just a sketch, but it gave me a starting point. So when I sub these values into base and height, I get the square root of 40 times the square root of 40, which really is the square root of 40 all to the exponent of 2. Square root and square are opposites to each other, so they undo each other and leaves me with just positive 40 on the top, divided by 2, which gave me 20 as my answer for my area. So the area of triangle PQR is 20 square units.